Okay, students, good morning. Today we'll do some question from Compulsory Mathematics, class 9, Math Things 2022 edition, page 231. Today's our topic is indices. Let's start from question number 4. Question number 4a. Solution here. On 4, we have to simplify the given question. Here, cube root 4x to the power 5 y to the power 7 multiply with cube root 2x to the power 4 y square. This equal to, since order is same, cube root, this is also cube root, so putting together in a single root. Cube root 4x to the power 5 y to the power 7 multiply with 2x to the power 4 y square. This equal to cube root, this 4 to the 8, so it is 2 cube. 4 to the 8. X to the power 5, here 4, so x to the power 5 plus 4, y to the power 7, here 2, so 7 plus 2. This equal to cube root 8 x to the power 9, y to the power 9 equal to cube root 2 x cube y cube, its whole power 3. So this equal to 2x cube y cube. Okay, students, now we go to question number B. Now look at 4b. Here, fourth root to the power minus 1 x to the power 7 multiply with fourth root 32 x to the power minus 3. Okay, students, this equal to, since order is same 4, so putting in the single root, fourth root 2 to the power minus 1 x to the power 7 dot 32 x to the power minus 3. This equal to fourth root 2 to the power minus 1, that is 1 by 2. This coefficient is 32. Then x to the power 7 minus 3 equal to fourth root 32 divided by 2, that is 16. X to the power 7 minus 3, that is 4 equal to fourth root 2x whole power 4. Since 2 to the power 4 is 16, so order is 4, power also 4, so this equal to 2x. Now we go to next question, 4c. On 4c, we are given that fourth root 128 a cube divided by fourth root 2 to the power minus 1 a to the power minus 9. This equal to, since order is same, so we can put in the single root. Fourth root 128 a cube upon 2 to the power minus 1 a to the power minus 9. This equal to fourth root 128 2 to the power 1 A to the power 3 plus 9. This negative power becomes positive when moving up. Now, fourth root 128 to the 256. A to the power 3 plus 9, 12. This equals to fourth root 256, that is 4 to the power 4. So 4 a to the power 12, that is a cube whole power 4. So 4a cube whole power 4. This equals to 4a cube, since order and power are the same. Now we go to next question, question number 4D. Now students, look at 4D. On 4D we have fourth root 32 x to the power 7 y to the power 11 multiply with fourth root 8x to the power 5 y to the power 5. Since order is same, so putting in the single root. Fourth root 32 x to the power 7 y to the power 11 multiply with 8 x to the power 5 y to the power 5. This equals to fourth root 32, that is 16 times 2. So 16 times 2 and coefficient of here 8. Then x to the power 7 plus 5 y to the power 11 plus 5. This equals to fourth root 16 to the power 4. 2 times of 8, 16 again to the power 4. So 2 times 2 whole power 4 x to the power 7 plus 5 12 y to the power 11 plus 5 16. This equals to fourth root 2 to the 4 x cube y to the power 4 its whole power 4. So answer is 4x cube y to the power 4. Now students, we go to next question, 4E. On 4E, we have given that cube root 24 x to the power 7 y to the power 11 divided by cube root 3 x to the power 4 y to the power 5. Okay, since order is same, so we can put in a single root. Cube root 24 x to the power 7 y to the power 11 upon 3 x to the power 4 y to the power 5. This equals to cube root 24 divided by 3. It becomes 8. X to the power 7 minus 4 y to the power 11 minus 5. This equals to cube root 8 x to the power 7 minus 4, that is 3 y to the power 11 minus 5, that is 6. Cube root sorry 2xy square whole cube. Since 2 cube is 8, x whole cube is x cube, y square whole cube is y to the power 6. So order and power is same, so this equal to 2x y square. Okay students, now next question. Oh yeah. we have here we have fourth root 32 x to the power 7 y to the power 11 divided by fourth root 2x cube y to the power 7. Since order is same, so we can put in the single root. Fourth root 32 x to the power 7 y to the power 11 upon 2x cube y to the power 7. 32 divided by 2, that is 16. So fourth root 16 x to the power 7 minus 3 y to the power 11 minus 7. This equals to fourth root 16 x to the power 4 y to the power 6. Fourth root 2x y squared 2xy whole power 4. No, 11 minus 7 here must be 4. So 2xy whole power 4. This equal to 2xy since order and power are same. Now we go to the next question. 4g. On 4g, we have given that fourth root 8 x to the power 5 y to the power 7 multiply with fourth root 2x to the power 7 y. Since order is same, so we can put in the single root. Fourth root 8 x to the power 5 y to the power 7 multiply with 2x to the power 7 y. Okay student, this equal to fourth root 8 to the 16 x to the power 5 plus 7 and y to the power 7 plus here no power, that is 1. So this equal to fourth root 16 x to the power 12 y to the power 9 equal to fourth root 16, that is 16 x to the power 12 y to the power 7 plus 1 here 8, here must be 8. So it becomes fourth root 2x cube y square whole power 4 to the power 4 is 16 x cube whole power 4 is x to the power 12 y square whole power 4 is y to the power 8. So order and power are same, so answer is 2x cube y square. Okay students, now question number 4 years. On 4 years we have cube root 56 x to the power 7 y to the power 11 whole upon cube root 7 x to the power 4 y to the power 5. Since order is same, so put in the single root. Cube root 56 x to the power 7 y to the power 11 upon 7 x to the power 4 y to the power 5. Cube root 56 divided by 7. 7 8 the 56. So 8 y to the power x to the power 7 minus 4, y to the power 11 minus 5. This is equal to cube root 8x cube y to the power 6, cube root 2x y square whole cube. This is equal to 2x y square, since order and power are same. Now we go to the next question. 4i. And 4i we have cube root 16 x to the power 7 y to the power 7. It is open. Cube root 2 x to the power 4 y. Okay, since order is same, put in the single root. So cube root 16 x to the power 7 y to the power 7 upon 2 x to the power 4 y. This is equal to cube root 16 divided by 2, that is 8 x to the power 7 minus 4 and y to the power 7 minus 1. No power means power 1. So cube root 8 x to the power 3 y to the power 6. This is equal to cube root 2x y square whole cube. Order and power same, so answer is 2x y square. Order and power cancel each other. Now, students, we go to question number 5. In question number 5, again we have to simplify the given question. Let's start from 5a. X to the power a upon x to the power b. Its whole power is a square plus ab plus b square multiplied with x to the power b upon x to the power c. Its whole power is b square plus bc plus c square multiplied with x to the power c upon x to the power a. Its whole power c square plus ca plus a square. So first step, this is equal to x to the power a minus b. Lower power moving up, so sign change, so minus b. Its whole power is a square plus ab plus b square dot. In second part, x to the power b minus c whole power b square plus bc plus c square dot. X to the power c minus a whole power c square plus ca plus a square. Now this equals to first part multiplied with second part, a minus b multiplied with a square plus ab plus b square. It makes a cube minus b cube form. So x to the power a cube minus b cube. Similarly, in second part, x to the power b cube minus c cube. In third part, x to the power c cube minus a cube. Since base are same, so power can be added. X to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. Since all are positive and negative in the pair, so the sum of power is 0. X to the power 0, that is 1. Okay, students, now we go to next question, 5b. On 5b, the question is x to the power 2l upon x to the power 2m. Its whole power is 2l square plus 2lm plus m square multiplied with x to the power 2m upon x to the power 2m. Its whole power 2m square plus 2mn plus 2n square. Multiply with x to the power 2n upon x to the power 12. This whole power is 2n square plus 2nl plus 2l square. Okay students, first step is equal to x to the power 2l minus 2m whole power 2l square plus 2lm plus here must be 2m square plus 2m square dot x to the power 2m minus 2m is whole power 2m square plus 2mn plus 2n square dot x to the power 2n minus 2l whole power 2n square plus 2nl plus 2l square. This equal to x to the power, here 2 common, here also 2 common, so it makes 2 to the 4. So x to the power 4 times l minus m l square plus lm plus m square dot x to the power 4 times m minus n m square plus mn plus n square dot x to the power 4 times n minus l n square plus nl plus l square. Since 2 common from first part, again 2 common from second part, so 2 to the 4, the remaining part is that. So next step, x to the power 4 times, this makes a cube minus b cube form, so l cube minus m cube. Similarly in the second, x to the power 4 times m cube minus n cube dot x to the power 4 times n cube minus l cube. So base is same, so x to the power 4 common from all three, so remaining parts are l cube minus m cube plus m cube minus n cube plus n cube minus l cube. So x to the power 4 times, within bracket sum is 0, so 4 times of 0, x to the power 0, so this is equal to 1. Okay students, now we go to next question, question of 5c. On 5c, we have a to the power x divided by a to the power y. A to the power x divided by a to the power y whole power x square plus xy plus y square. Multiply with a to the power y divided by a to the power z. Its whole power is y square plus yz plus z square. Multiply with a to the power z divided by a to the power x whole power z square plus zx plus x square. Okay, this is equal to a to the power x minus y. In divide, power is subtracted since base are same. A to the power x minus y whole power x square plus xy plus y square. Multiply with a to the power y minus z whole power y square plus yz plus z square. Multiply with a to the power z minus x whole power z square plus zx plus x square. So first part a minus b form, second part a square plus ab plus b square form. So it makes a cube minus b cube form. So e to the power x cube minus y cube. Similarly in second, a to the power y cube minus z cube. In third, a to the power z cube minus x cube. Since base are same, so power can be added. A to the power x cube minus y cube plus y cube minus z cube plus z cube minus x cube. Since the sum of the power becomes 0, so a to the power 0, so this equal to 1. Okay students, now we go to next question, 5D. On 5D, here we have x to the power 3a divided by x to the power 3b. X to the power 3a divided by x to the power 3b. Its whole power is 3a square plus 3ab plus 3b square. Multiply with x to the power 3b divided by x to the power 3c. Its whole power is 3b square plus 3bc plus 3c square. Multiply with x to the power 3c divided by x to the power 3a. Whole power 3c square plus 3ca plus 3a square. Now first step is equal to x to the power 3a minus 3b. Whole power 3a square plus 3ab plus 3b square. Multiply with x to the power 3b minus 3c whole power 3b square plus 3bc plus 3c square. Multiply with x to the power 3c minus 3a whole power 3c square plus 3ca plus 3a square. Since 3 is common in the first part and in second part, so from taking common 3 from first part and second part, it becomes 3 3 is 9. So x to the power 9 times a minus b, a square plus ab plus b square. In the second, again same, x to the power 9 times b minus c, b square plus bc plus c square. In the third, again 3 common from first part and second part, so x to the power 9 times c minus a, c square plus ca plus a square. Now it makes a minus b, a square plus ab plus b square. It makes a cube minus b cube form in all parts. So x to the power 9 times a cube minus b cube multiplied with x to the power 9 times b cube minus c cube multiplied with x to the power 9 times c cube minus a cube. Since 9 is common from all parts, so base same, x to the power 9 times a cube minus b cube plus b cube minus c cube plus c cube minus a cube. So x to the power 9 times, within bracket the sum of power is 0, so 9 times 0, so x to the power 0, that is 1. Okay students, we go to next question, question number 5E. Question number 5E, we have x to the power a square plus b square upon x to the power minus ab. Its whole power is a minus b. Multiply with x to the power b square plus c square all upon b square plus x to the power b square plus bc all upon x to the power minus c square. Its whole power is b minus c. Multiply with x to the power c square plus ca all upon x to the power minus a square. Its whole power is c minus a. Okay, students, in the first step, we can move up this lower part in the upper side. So, x to the power a square plus ab plus b square. Putting ab in the middle position. When ab becomes positive when moving up. Its whole power is a minus b. In second part, x to the power b square plus bc plus c square. Now c square becomes positive. Its whole power is b minus c. Dot. In third, x to the power c square plus ca plus a square. This negative a square becomes positive. Its whole power is c minus a. Now let us take first part and second part. This first part is a square plus ab plus b square. Second part is a minus b. So it makes a cube minus b cube form. So x to the power a cube minus b cube from the first. Multiply with x to the power b cube minus c cube from the second. Similarly, x to the power c cube minus a cube from the third. Since base are same, so power can be added together. X to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. Since sum of power is 0, so x to the power 0. So answer is 1. As you know, something power 0 is 1 except the base 0. When base is 0, in this case, undefined. Now, students, question number 5. Yeah. Let's start. Next question. 5. Yeah. On question number 5. Yeah. We have x to the power a square plus b square whole upon x to the power ab. Its whole power is a plus b. Multiply with x to the power b square plus c square whole upon x to the power bc. Its whole power is b plus c. Multiply with x to the power c square plus a square whole upon x to the power c. Whole power is c plus a. Now this equal to x to the power a square minus ab plus b square. This ab power moving up, so sign change, it becomes negative. Whole power is a plus b dot x to the power b square minus bc plus c square whole power b plus c dot x to the power c square minus ca plus a square whole power is c plus a. Now this equal to first part and second part in the form of a plus b, a square minus ab plus b square. It makes a cube plus b cube form. So x to the power a cube plus b cube from the second x to the power b cube plus c cube multiplied with formula third x to the power c cube plus a cube. So basically same power can be added. So x to the power a cube plus b cube plus b cube plus c cube plus c cube plus a cube. So in the power a cube are repeated 2 times, b cube 2 times, c cube also repeated 2 times. So x to the power 2 times of a cube plus b cube plus c cube. Okay, this is the answer. Now we go to next question 5G. Question number 5G. Here we have x to the power l square plus m square all upon x to the power minus lm. Its whole power is l minus m multiplied with x to the power m square plus n square all upon x to the power minus mm. Its whole power is m minus n multiplied with x to the power n square plus l square all upon x to the power minus nl. Its whole power is n minus l. Okay, students, this is equal to x to the power l square plus lm plus m square. This negative lm moving up, it becomes positive. Its whole power is l minus m. On the second, x to the power m square plus mn plus n square. Whole power is m minus n multiplied with x to the power n square plus nl plus l square. Whole power is n minus l. Since first power and second power, it makes a cube minus b cube form. So x to the power l cube minus m cube. Similarly, x to the power m cube minus n cube. Similarly, in the third, x to the power n cube minus l cube. Since base are same, power can be added together. So x to the power l cube minus m cube plus m cube minus n cube plus n cube minus l cube. Since in the power the sum of power becomes 0, so x to the power 0, so this is equal to 1. Now we go to next question 5s. Now students, look at question number 5s. On 5s, we have x to the power a plus b all upon x to the power c. Its whole power is a minus b multiplied with x to the power b plus c all upon x to the power a. Its whole power is b minus c multiplied with x to the power c plus a all upon x to the power b. Its whole power is c minus a. Now on the first step, this equal to this lower power moving up, you can write x to the power a plus b minus c whole power a minus b multiply with x to the power b plus c minus a is whole power b minus c multiply with x to the power c plus a minus b whole power is c minus a. Now first power and second power. does not make formula, so multiply each other. So multiplication a plus b multiply with a minus b. Here partially we can use formula of a square minus b square. A plus b, a minus b, a square minus b square. Similarly, b plus c, b minus c, b square minus c square. C plus a, c minus a. It makes c square minus a square. So x to the power a square minus b square. Now count of minus c multiply with a minus b. Minus c times a minus c, minus c times minus b, minus minus plus bc dot. In the second, b plus c times b minus c, b square minus c square. Now minus a with b minus c, minus a times b minus ab, minus a times minus c, minus minus plus c dot. In the third, c plus a, c minus a, it makes c square minus a square. Now minus b with c minus a, minus b into c minus bc, minus minus plus b to a ab. Since base are same, so power can be added. X to the power a square minus b square minus ca plus bc plus b square minus c square minus ab plus ca plus c square minus a square minus bc plus ab. Now this equal to x to the power. In the power, the sum of all power becomes 0. Positive a square, negative a square. Negative b square, positive b square. Negative c square, positive c square. Degree 2 terms cancel. Now negative ca, positive ca. Positive bc, negative bc. Positive ab, negative ab. So all cancel each other, so its power is 0. So answer is 1. Okay students, now we go to question number 5i. Okay, let's start 5i. On question number 5i, we are given that x to the power l plus m upon x to the power l minus m. Its whole power is n minus l. Multiply with x to the power m plus n upon x to the power m minus n. Its whole power is l minus m. Multiply with x to the power n plus l all upon x to the power n minus l. Its whole power is m minus l. Okay students, now first step, this equal to downside power moving up by changing its sign. So x to the power l plus m minus l plus m whole power n minus l. Similarly on the second, x to the power m plus n minus m plus n whole power l minus m multiply with. On the third, x to the power n plus l minus n plus l whole power m minus n. Okay, downside power moving up. L becomes negative, m becomes positive. M becomes negative, n becomes positive. N negative, this minus l positive. Sign change for the power. Now here l cancel, m plus m 2m. X to the power 2m times n minus l. X to the power here n plus m 2n times l minus m. In third, x to the power 2l times m minus m. Now first power, second power multiply each other. X to the power 2mn minus 2ml. In second, x to the power 2nl minus 2mn. In the third, x to the power 2ml minus 2nl. Since bases are same, power can be added together. 2mn minus 2ml plus 2nl minus 2mn plus 2ml minus 2nl. Since sum of all powers becomes 0, so answer is 1. Now students, we go to next question, 5J. On 5J, we have xy dot a to the power x upon a to the power y. Xy dot a to the power x upon a to the power y. Multiply with yz root a to the power y upon a to the power x. Sorry, a to the power z. Multiply with zx root a to the power z upon a to the power x. Now this equal to this downside power moving up, a to the power x minus y. Its whole power is 1 upon xy. Removing the root, this order becomes as denominator. Multiply with, in second, a to the power y minus z. Whole power is 1 upon yz. Multiply with, on third, a to the power z minus x. Whole power is 1 upon zx. Downside power moving up with changing sign and removing radical sign, giving as power. Order becomes denominator of the power. Now first power multiplied with second power, it becomes a to the power x multiplied with 1 by x. X cancel, 1 by y. 1 by y. Minus y multiplied with 1 upon xy. Y cancel, remaining 1 by x. Similarly on the second, a to the power y multiplied with 1 by yz. Y cancel, 1 upon z. Minus z into 1 by yz. Z is cancel, 1 by y. On the third, a to the power z into 1 by zx. Z cancel, 1 by x. Similarly, x into 1 by zx. X cancel, 1 by z. Since bases are same, power can be added. A to the power 1 by y minus 1 by x plus 1 by z minus 1 by y plus 1 by x minus 1 by z. Since sum of power, that is 0, so a to the power 0, that is 1. Now we go to next question, 5k. On 5k, we have AB root m to the power a by b upon m to the power b by a. Multiply with BC root m to the power b by c upon m to the power c by b. Multiply with AC root CA root m to the power c by a upon m to the power a by c. Okay, first step, moving the downside power in the upper side. So m to the power a by b minus b by a is whole power 1 upon AB, moving root also. Multiply with m to the power b by c minus c by b. Whole power is 1 by bc. Multiply with m to the power c by a minus a by c. Whole power is 1 upon ca. Now first power multiply with second power. M to the power a by b into 1 by ab. In this case, a cancel, b into b multiply each other. So 1 by b square minus b by a multiply with 1 by ab. b cancel, a into a square. So 1 by a square. In the second, m to the power b by c into 1 by bc. b cancel, 1 by c square. Minus c by b into 1 by bc. cc cancel, 1 by b square. In the third, m to the power c by a into 1 by ca. cc cancel, a into a square. 1 by a square. Minus a by c into 1 by ca. A cancel, c into c square. So 1 by c square. So this is equal to base system. Power can be added. M to the power 1 upon b square minus 1 upon a square plus 1 upon c square minus 1 upon b square plus 1 upon a square minus 1 upon c square. On the power, the sum of power becomes 0. So m to the power 0, that is 1. Okay students, we have finished question number 5K. This was for today. Have a nice time. See you soon.